put up the screen and see what we're looking at this week for Algebra 2. All right, so looking at third hour.
You should. All right, let's see how long we have in your head because it's been going in and out.
There's a lot of noise coming out of your room today.
Oh, sorry.
That's all right, no problem.
I forget to mute because I'm still getting used to having someone here.
I understand.
I'm used to being by myself. Still getting used to it. Hang on.
Okay, so looking at this week, we only have one lesson and a quiz. So this will be a little bit easier week. And we've got a couple things coming the next week. So this week we have 2.03, solving radical equations. And then we have a quiz over radical and polynomial operations. So last week we did a lot with rationals and radicals. This week we're going to talk about solving radicals. And so that's what you have this week. Hopefully you've got everything caught up and turned in. If you didn't do well on something, you can retake it. Several of these items in Buzz have automatic retakes that'll let you do that automatically. If you have something like the test that it only lets you take it once and you didn't do well, email me. I do allow retakes. I may ask you a question or two when you email me and say, I want to retake the test. I may send you a problem and say, well, okay, have you looked at this problem? How are you supposed to do it correctly? But then I will reopen the test for you. So don't fret. If you have a poor score, you have the opportunity to redeem yourself. All right, let's look at 2.03. Go back to the activity screen. Module 3, solving radical equations lesson. Eventually. In addition to going out, it's loading slow today too. Okay, defining radical equations. All right, so we haven't really talked about how to solve them yet, but we've seen them in action. So here's the time it takes for a pendulum to complete one full swing to one side and back again, can be found with this equation. Time equals 2 times pi, the square root of L divided by 32, which I would assume L is the length of the string that's holding the pendulum. So if you ever play with a yo-yo, the longer the string, the longer it's going to take for the yo-yo to get back where it started. So that's the same with a pendulum. The longer the string, the longer it takes. So the bigger that L is, the longer it's going to take. So T represents the time in seconds for one pendulum to swing. L stands for the length of the string, and 32 represents the force of gravity on the Earth's surface. So a radical equation that can be used in real life situations. So what we're going to learn about is what reasoning and explanations can be used when solving radical equations, and how do extraneous solutions arise. Extraneous, that usually means extra, something you can throw away, it's really not relevant. So we're going to get into that. Here's some review if you need it. Okay, so here's a review over identifying radical equations. You got to learn how to recognize and define one. So I'll open it up so we can look at it real quick. This is not a radical equation. The square root of x plus 2 equals 7. Oh, I'm sorry, that is a radical equation. The next one is not. X plus the square root of 2 equals 7. That's not a radical equation because the square root of 2 is actually a number. There's a value for that. It's a number. Square root of x is a radical equation because that is going to change based on the value of x. So that's the difference between a radical equation. Just because there's a square root or a cubed root or a fourth root or a fifth root in the equation does not mean it's a radical. It's only when the variable is underneath the radical symbol that it counts as a radical equation. So it says that the variable's inside the radical, the second one's outside. So a radical equation can be defined as an equation containing a radical where the variable is or is a part of the radicand. That's what you call what's underneath the radical, the radicand. So it has a little test. If you're not sure, I'm not going to do all of these here in class, but if you're wondering, if you're confused, do you not know the difference, this has you drag this. Is this radical? Is this not radical? And it'll give you several of these to try. That's a radical. There's an X underneath there. So if you want to try those just to make sure you're good, That's the review. Here's another review. I'll show that real quick. Review on solving equations. So if you have x plus 4 minus 7, you subtract 4 from both sides, because to solve is to figure out what the variable equals. So in this case, the variable equals negative 11, because negative 11 plus 4 equals negative 7. These are all very basic ones. This is one you subtract, this one you add, this one you divide, this one you multiply. All right, x divided by 8 equals 2. Multiply both sides by 8, x equals 16. Right? And then with like a square, x squared, what's the opposite of that? That's the square root. So you take the square root of both sides. And you get two answers, because 6 and negative 6 both are squared to equal 36. That's why there's two answers, because they both will produce the perfect square of 36. So a review of solving equations. All right. So what operation would you use to solve an equation like the square root of x equals 4? Well, you've got to do the opposite of that. If we want x to be by itself, we don't want the square root of x, we want x. So if you have the square root of x, we would need to square both sides. So the square root of x times the square root of x is x. The square root and square cancel each other out. So x equals 16. Right, and there's a definition underneath there if you need a refresher on that. Square root of x squared is the square root of x times the square root of x, which is the square root of x times x, which is the square root of x squared, which means it's just x, because those cancel each other out. All right, let's look at our lesson here. That was review information. Okay, so let's apply this knowledge to some examples here. If we need to solve this equation, the square root of 5x plus 4 equals 7. All right, I'm going to put this on paper so we can play with it. 5x equals 7. Okay, I'm going to put this up on the screen. Okay, so if we're needing to solve that, which means we need to isolate the x. We need to get it to x equals. That's what we're looking for. When you're solving, you're trying to figure out what the variable equals. So we have to unravel everything that is around this x. The first thing we see here is 5x plus 4 is in parentheses, and it's all underneath the radical. It's taking the square root of everything underneath there. So the first thing we need to do is square both sides. Let's square everything. Right? So the square root of 5x plus 4 times the square root of 5x plus 4. Right? It's the square root times the square root. Well, when you square a square root, they cancel each other out. So this just equals 5x plus 4 equals 7 squared. Just think of it. This is just like the square root of 3 times the square root of 3. Well, that's the same as the square root of 3 times 3, which is the square root of 9. What's the square root of 9? 3. See, it just cancels out the square root. If you take it times itself and it's the square root, you're going to get whatever the radicand is. It's going to be the answer. So in this, if we do the same thing, whatever the radicand is going to be the answer. It's 5x plus 4. Cancels each other out. Okay, now we're down to just solving the equation. So we're going to subtract 4 from each side. 5x equals 7 squared is 49. 49 minus 4. We got 5 times x equals 45. So we need to do the opposite. Of course, this is back to Algebra 1 and earlier stuff, just solving this now. So this is kind of a review here. 45 divided by 5. So x equals 9. So we started off with this really nasty looking thing here. Square root of 5x plus 4 equals 7. We got 9 as an answer, so let's test that. 5 times 9 plus 4. All right, because we're just substituting our solution. Our solution is 9, so that means we should be able to put a 9 in there. So this is the square root of 45 plus 4. 45 plus 4 is 49. Square root of 49 would equal 7. There's also a negative 7, but this does equal. This is a true statement. This is a solution for that because it's true when we put the 9 back into the x. So we're good on that. All right. So this says isolate the radical. Let's go through the steps like they do right here. First thing they do is square both sides. That's what we did. Then their next step is to subtract the 4 from both sides because you have 5x plus 4 equals 49. That gets it down to 5x equals 45. Divided by 5, x equals 9. What we just come up with. And then they checked it just like we did. We substitute the 9 back in and we get 7 equals 7. All right. See, they give another example. Okay, this is good. Let's work another example here. X minus 3 plus 4 equals 1. Okay, we don't want to square both sides yet because while this is under the radical, this is not. These are two separate terms. Before we square both sides, we want to have the radical by itself. That's the only thing on that side of the equal sign. This is not the case. We have something else on the other side. So let's subtract 4 first and get that moved. X minus 3 equals 1 minus 4. All right. Now, the only thing on this side of the equal sign is the radical. So we can square both sides. Square root of x minus 3 times the square root of x minus 3 is x minus 3 equals negative 3 squared, which is 9. Because negative 3 squared is 9. It's not negative 9. If you try putting that in a calculator and don't put parentheses around the negative 3, it'll tell you negative 9. Make sure you put parentheses when you're squaring that. If you have a negative, you want that in there. So now we have x minus 3 equals 9. Add 3. X equals 12. Let's check our work. 12 minus 3. Since that's what x equals, it's 12. 12 minus 3 plus 4 equals 1. This is 12 minus 3, so that's the square root of 9 plus 4 equals 1. It's going to be an interesting case here. What's the square root of 9? 3 plus 4 equals 1. Wait a minute, what happened there? 3 plus 4 does not equal 1, but that's what it got with the solution right there. This is one of those cases. They're going to work it right here. Oh, wait. So they're working it just like we worked it. So they subtract 4 from both sides. They squared both sides then. X minus 3 is 9. And they got x equals 12. Then when they checked it, is 12 a solution? No, there's no solution. This is an extraneous solution. It actually, we can solve and get this number, but when we check it, it doesn't work. Extraneous. I'm going to write that on our... and put that on our page there. Even though we were able to mathematically come up to a solution to this equation, when we tested it, it said 7 equals 1, which is not true. So there's no solution to this. It's one of those cases where the other square root of 9 would be negative 3 plus 1. It would work. But there's no way we can get this to equal negative 3. Because when you take the square root of something, it's got to be a positive number. Because it would be negative 3 plus 4 would equal 1. No solution. So if you do not check it, if you do not go through this, you will get it wrong because you'll say, here's the solution. But it's not. That's an extraneous solution that has to be thrown away. Extraneous solution. Even though we solved it, it doesn't work when you check it. So that's where extraneous solutions come from. An extraneous solution is a solution to an equation that does not fit the requirements of the original equation. So it's technically a solution of that equation, but it doesn't work. Let's look over our third example here. Two radicals. All right. So the purpose of isolating the radical so the radical could be eliminated and squaring both sides equal sign. So in this case, this is fine. We can do this. Square root of 3x plus 7 equals the square root of 19. Well, that should be all right, because if we square both sides, it should just be 3x plus 7 equals 19. Because if you square that, the square root goes away. If you square that, the square root goes away. We end up with just this equation. Minus 7 minus 6. What are you doing, Mr. Brock? Minus 7, 3x equals 19 minus 7 is 12. Divide by 3, x equals 4. Now, we learned from this one, we have to check any solution when we're solving radicals. So does 3 times 4, the square root of 3 times 4 plus 7 equal the square root of 19? So what is 3 times 4? Well, that's 12 plus 7. 12 plus 7 is the square root of 19. Does the square root of 19 equal the square root of 19? Well, yes, it does. I don't know what that number is. It's like, 4.6 or 4.4 or something. I don't know. Our calculator could tell us what that is. If we really want to know what's the square root of 19, let's see, 19 square root. It's 4.358, 89435. All of those. Doesn't matter what it is. It's equal to itself. So this checks out. This is the solution. X equals 4. Because it works out. That's a true statement. And they work through it in here as well. They get x equals 4. And then when they check it, square root of 19 does equal square root of 19. Okay, so that's solving radical equations. Let's go on to important information about extraneous solutions. Okay, let's see what this important information is. Note that in example 2, when checking your work, the square root of 9 was found to be 3. If the square root of 9 was simplified to negative 3, it would have checked out. Right, square root of 9, negative 3 plus 4 would be 1. However, an assumption is made when solving radicals that the square roots will only be simplified to their positive integers. Otherwise, you can always get a solution that checks out even when it won't. So that's why you must check your answers, and we're always going to simplify it to the positive integer when you're checking it, when you're taking the square root. We're going to default to the positive. So, all right. Learn more on solving basic radical equations. Let's see what other information they're hiding in this link. Okay, so this is just another step like this. We have 3 on the outside. 3 times the square root of x plus 7 equals 12. Well, just like before, when we had the square root of x minus 3 plus 4, we have to deal with everything not under the radical first. We got to get the radical by itself. So the first thing, it's multiplied by 3. So let's divide both sides by 3. See, when they do that, now you have the square root of x plus 7 equals 4. Because they divided the 12 by 3. Now you can square both sides. We have the radical by itself. Remember, you always have to get the radical by itself before you square both sides. So let's look at their next step. Oh, that's it. Step 2 is over here. So when we got the square root of x plus 7, and we square that, x plus 7 equals 4. Now it's squaring both sides, you get x plus 7 equals 16. Okay, so the next step, what is x going to equal? X plus 7 equals 16. We subtract 7. X equals 9. Let's check it. 3 times 9 plus 7 equals 12. 3 times the square root is 16. 3 times 4, 12 equals 12. So 9 is the solution. We checked it. It does work. It's not extraneous. All right. Now here's some for you to try. I'm not going to do all of these in class because this is where you pull out some pencil and paper and you write down this problem and you get a solution and then see if it matches one of these 4. All right. So you're going to see if it matches one of those 4. You're going to say, okay, I've worked all that, Mr. Brock. It's 14. I'm going to submit. Oh, good. But if you got it all and you thought it was 1.6, it would have told you were wrong. So there's 6 sample problems there for you to test. And possibly even no solution if it's extraneous. All right. Let's go to look at page 3. All right. Quick review of factoring. Because sometimes when we're squaring things, we're going to get a quadratic. Right? So which means we have to factor to solve quadratics. So remember, like on this case, x squared plus 2x. Yeah, well, let's just do this on paper so we can talk about it step by step instead of trying to sort through the whole thing there. All right, I've got it written down there. Factor by grouping, it said. So what I did on that, they were grouping theirs. Okay, I see what they were doing. So they said, okay, what would this be? So they had the right there where they took the 15. They said negative 15 would be 1 and 15, 3 and 5, and that's about it. There's nothing else that multiplies together to be there. But if we need it to be a positive 2, we can make a negative 3 and a positive 5. So we would change this to x squared. So 2x would become negative 3x plus 5x. See, this is the same thing. I just rewrote as this with a minus 15 at the end. So then we can group it. We can take this and take this. What can we factor out of x squared minus 3x? Well, there's a 1 and a negative 3. We can't factor anything out there, but they both have an x. So if we factor an x out of x squared and we factor an x out of negative 3x, we have that. Plus, because we have a plus there, 5x and negative 15. 5x and negative 15. The only thing they have in common is we can pull a 5 out. So 5 out of 5x leaves just an x. 5 out of negative 15 leaves a negative 3. Now I've still got 2 terms. I've got this term here, x times x minus 3. And I've got this term, 5 times x minus 3. We can factor out, both of them have x minus 3. So we can factor that out. So what's left there? If we factor out an x minus 3, all that's left is an x. If we factor out an x minus 3 of this term, all that's left is the plus 5. So that's the factors, x minus 3 and x plus 5. We factored it. If we were solving it, we'd set it equal to 0. So either x minus 3 equals 0 or x plus 5 equals 0. In either case, if one of those is 0, it will end up 0. So x equals 3, x equals negative 5. There's the 2 solutions to this quadratic equation right there. So they went through the same thing, x plus 5, x minus 3. Okay, they give you a video for this one, so I don't have to work that because you can watch this whenever you need to review it. It's 4 minutes, 25 seconds. A new type of example that has variables inside. Oh, I just want to see what the problem is. Okay, this says the square root of x plus 9 minus 7 equals x. So when you square that, you add the 7 to it and then square it, you're going to have x plus 7 squared, which turns into a quadratic equation. Here, if I make that bigger, you can see that without that being in the way so bad. when you square that, you get x plus 7 times x plus 7, which simplifies to x squared plus 14x plus 49. And you move everything to one side, you end up with this quadratic equation. X squared plus 13x plus 40, which they're now going to factor as they move down and get their two solutions. And then they have to check both solutions. Since they got two solutions, they have to check them both. Look, this one turns out to be extraneous. -6 does not equal -8. So when they got two solutions, one of them is thrown out as extraneous. But watch that video on your time. I won't take class time for something you guys can watch all yourself. So, all right. Wow, that's the lesson summary. Let's review squaring both sides of an equation. There's a little review button to click here. Squaring each term. So if you had 2 plus x equals the square root of 7, right? You can't square the 2 and the x separately. It's not 4 plus x squared because you have to square the whole thing together. The entire side is squared. So if you just squared the terms, the 4 squared, let's say x equals 3. For some reason, they put an x equal 3. Because 4 plus 3 equals 7. So if you had 4 plus 3 equals 7 and you squared it, you would get 4 plus 9 equals 49, or 16 plus 9. That doesn't work if you just square the terms individually. If you square the whole thing, 4 plus 3, or the 2 plus 5, that'd be 7. 7 squared equals 7 squared. So if you're squaring both sides and they have two different terms, you have to put parentheses around the whole thing and square the whole thing like they showed right there. Square the whole thing. That's a nice reminder. Just a review again on how to square both sides. If you need more examples, here's Learn More, solving radical equations with variables outside the radical. See what example they give here. So if you have the square root of x minus 3 plus 3 equals x, right? Slide 1 of 8. First thing we're going to need to do, we have a radical, but there's something that's not included. So we're going to have to move that. See, so they have to subtract 3 from both sides and move it. Now they've got the square root of x minus 3 equals x minus 3. Wow, I wonder what x is going to be to make that work. But we have the radical by itself, so we're going to square both sides, which means we're going to square x minus 3 and just end up with x minus 3 because that's the square root of that one. On the other side, that's going to end up a quadratic. See, because we have to square that. So x minus 3 times x minus 3 is x squared minus 6x plus 9. That's what that turns into. Where over here, it just gets rid of the radical. Now we've got to combine all that on the same side, move the 3 over, move the x over, move the 3 over. Now we've got a quadratic, which we have to factor. So they're looking at the factors of 12. Since we have 12 in the end, you can factor at 1 and 12, -1 and -12, 2 and 6, -2, -6, 3 and 4, -3 and -4. Well, the only ones that add together to be -7 is the last one. So we're going to take the -3 and -4 as the factors. Then you can solve it. X equals 3, x equals 4. You need to check them both. 3 equals 3, 4 equals 4. Both solutions checked out. So there's no extraneous solutions. There's only actual solutions. So that was another review problem. And you can review that. Lesson summary. Here's a great place to get your notes. And for this unit, I would have example problems written down as notes. So when I go take the test, I can look at my notes and say, oh, here's a problem. How'd they work that one? Okay, that's what I need to do in the test. Okay, lesson summary. Steps to solving. They give you an example problem. First, isolate the radical. So it's the only thing on that side of the equal sign. Square both sides. Solve for the variable, x in this case. And then you have to check it to make sure we don't throw out any solutions as extraneous. All right, and then it gives some more you tries. So this is where you figure out, do you know what you're doing? You solve this on paper, choose what you think is the solution. Well, I'm going to say this has no solution, and I'll check it. And I'll say, oop, that's incorrect. So it's going to give me another chance to fix my error and I can try again. Square both sides first. You'll have to solve that equation. So once I solve it, I'll get two answers and then I'll check them both and see if I have both answers, one answer, or the other answer. 6 practice problems right there for you to try so you know if you understand. If you can't do any of those, you blow all 6 of them, you look back at the examples they gave you, still can't figure it out, that's when you come see me on Wednesday or Friday this week and say, Mr. Brock, I'm not understanding this. I tried solving these equations they put in the lesson and I'm lost. So I don't think I should do the assignment yet until I try this. It's like, you're right, because we have an assignment and then a quiz. You don't want to do those if you don't know what you're doing. The next page has something. Oh, here it is. Okay, solve these radical equations and submit to see if you are correct. And there's 2 activities right here. Question 1 of 5. So they have 5 of them here that you will solve. Choose your answer and submit. Go to the next one. Choose your answer, submit. Go to the next one until you've done all 5. Then go to the second activity, and they'll give you a different kind. Solve this next. Solve this next. And you get 5 more practice problems. And that's it. So they give you like 15 practice problems in the lesson that will tell you if you're correct or not, and will tell you how to do it if you're wrong. And if you get through those and can do it, then you'll have absolutely no problem on the quiz or on the assignment. But you have to practice it. You have to do the practice problems and let it tell you if you're wrong or right. I can sit there and show you 40 examples, and you won't learn as much as trying the ones they have there in the lesson for you. Actually doing it yourself. Here's our assignment. We have 5 problems. They're all multiple choice. Solve for X, identify if it's an extraneous solution. So in this one, you have some solutions, and is it extraneous or not? So you might find the solution, but you also have to check it. Here's another one. What's the solution? Is it extraneous? Is it extraneous? Here's one where Eloise started to solve a radical equation. And she got down to these answers and said both of them are extraneous. They don't. What error did she make? Somewhere she made a mistake. So you've got to evaluate what Eloise did and say, oh, well, there's the mistake. She shouldn't have done that. And so hopefully you'll figure out one of these 4 choices. And then the last one, he's trying to solve the square root of 6x plus 4 equals 8. And on the way to the math factory, Charlie dropped the steps. He had the steps to solve that. And so you need to put them in order. What's the correct order that he should do? Should he do first, divide 2 from both sides, and then square both sides, and then subtract 8? Or, and here's your choices. So 3 of these are the correct steps. Put them in the correct order. Okay, that's it. Yeah, I know I want to leave. I didn't answer any questions. I understand. Give me some flack here from Buzz because I'm leaving without answering questions. Okay. I'll go ahead and show you the quiz while we're at it. If it'll let me go to that. Okay, it's loading it. All right, let me show you the quiz real quick as well. First off, let me point out the quiz gives you 2 attempts. So if you don't do well the first time, go back and look at what you missed. Go back and see why you missed it. Oh, I forgot a step. And as long as you got it understood, try again. But when you start, rewrite this radical as an expression with exponents. Starts as a radical, I have to rewrite it as an exponent. That's from our lessons last week. Rewrite this one that has an exponent as a radical. So you have to rewrite that as a radical. Simplify this expression. That's the powers we talked about last week. A power to a power. What's the simplified expression? Here's one from this week. Solve this equation for X. And then number 5 on the quiz, show all work to solve this for X. And then if it's extraneous, you need to show that it's extraneous. So here's your equation. You may have a different equation because there's a few, it picks one. But square root of x plus 6 minus 4 equals x. So you'll have an equation similar to that one, or perhaps even that exact one. But you have to show the steps, which you're like, show the steps. How do I do that? Well, all those examples in the lesson, they show the steps. That's what it's looking for. If you saw in the lesson the steps that I went through, same steps I did on paper, showing your steps. I added 3 to both sides. I squared both sides. I checked the extraneous solution. Show all of those steps. So that's it. That's what we have this week. We've been here about 45 minutes. I think that's enough algebra for today. Since you have a quiz and you have an assignment, and you got till Sunday night. Don't wait till Sunday night, though, guys. Get this done. Have yourself a nice long weekend by getting your stuff turned in and make it easier on yourself. So, all right, guys. We'll see you. Fat Bear Week is coming. That's just a plug I'm putting in. It's what they do in Alaska. You vote on the fattest bear. That's coming next week. I'll be promoting that. It's fun. See ya.